Hi dear students, last class we discussed about the discovery of electron, protons, neutrons, atomic number, mass number, etc. Today we are going to discuss about the atomic models. Today we are going to discuss about the structure of atom. Now, after the discovery of electron, proton, neutron, the main question was were these electron, protons and neutrons are occupied in an atom. So, were these electron, protons and neutrons are placed in an atom. Okay, after the discovery of electron, proton and neutron, the main question is were these particles, that is electron, proton, neutrons are placed in an atom. Okay, so there are four important models. There are lots of models, there are so many models, but we are going to discuss about only four models, and there are four important models which help us to identify the position of electron, protons and neutrons in an atom. So there are four important models which help us to identify the position of electron, protons and neutrons in an atom. The first among them is Thomson's atomic model, and this model was proposed by J.J. Thomson. So Thomson's atomic model was proposed by J.J. Thomson, and this model is also known as plum pudding model or watermelon model. Okay, the first and the foremost model is Thomson's atomic model, and this model was proposed by J.J. Thomson, and this model is also known as plum pudding model or watermelon model. And the second model proposed by Rutherford, second model was proposed by Rutherford, and that model is known as Rutherford's atomic model. Okay, now third model was proposed by Niels Bohr, and the model is known as Bohr model, Bohr atomic model. And the fourth model was proposed by Heisenberg and Schrödinger, and that model is known as quantum mechanical or wave mechanical model. Okay, so there are four important models which help us to identify the position of electron, protons and neutrons in an atom, and the four models are Thomson's model proposed by J.J. Thomson. Those models are also known as watermelon model or plum pudding model. Second model is model was proposed by Rutherford, and that model is known as Rutherford's atom model. Third model was proposed by Niels Bohr, and that model is known as Bohr atomic model. And fourth model was proposed by Heisenberg and Schrödinger. That final last model is known as quantum mechanical or wave mechanical model. So now we are going to study in detail about these four models. I'll start with J.J. Thomson's plum pudding model. or watermelon model or Thomson's model. And this model was proposed by J.J. Thomson. Now, according to this model, atom is a positive charge sphere. According to this model, atom is a positive charge sphere. Let this be atom, and atom is a positive charge sphere. It's a positive charged sphere. Atom is a positive charged sphere in which electrons are embedded. Embedded means they are firmly attached, in which electrons are embedded to make atom neutral. So according to J.J. Thomson plum pudding model, atom consists of a positive charge sphere. In which electrons are embedded. Embedded means they are firmly attached. So they are firmly attached on the atom to make atom neutral. This is plum pudding model or watermelon model or Thomson's atomic model, and this model was proposed by J.J. Thomson. Okay, according to this model, atom is a positive charge sphere in which electrons are embedded. They are firmly attached to make atom neutral. Now the main problem is this model cannot explain even the stability of atom. So this model cannot explain even the basic stability of atom. Okay, then comes second model, that is Rutherford's atomic model. Moving on to next model, that is Rutherford's atomic model, and this model was proposed by Rutherford itself. So this model was proposed by Rutherford itself. Okay, so second model is Rutherford's atomic model, and this model was proposed by Rutherford itself, and he proposed this model by conducting a set of experiments. Those experiments are known as alpha ray scattering experiments. So he proposed this model after conducting a set of experiments. Those experiments are known as alpha ray alpha rays scattering experiments, EXP, experiments. So second model was proposed by Rutherford, and this model is known as Rutherford's atomic model, and he proposed this model by conducting a set of experiments known as alpha ray scattering experiment. Now what is alpha ray scattering experiments? Alpha ray scattering experiment consists of a small thin gold foil. Let this be the thin gold foil. So a thin gold foil, okay, and a stream of alpha particle, okay, a stream of alpha particle is projected, to this thin gold foil. A stream of alpha particles projected to this thin gold foil. This is alpha rays. So a thin gold foil, we took a Rutherford took a thin gold foil, and he projected alpha rays to this thin gold foil. Now here there are screen, here also there is one screen. Okay, now this screen is coated with zinc sulfide. The screen is coated with zinc sulfide. This screen is coated with zinc sulfide. Okay, this screen is coated with zinc sulfide. Now what is the importance of zinc sulfide? What is the peculiarity zinc sulfide? When an invisible radiation strikes on zinc sulfide, it will produce flash of light, scintillation, right? So he projected a stream of alpha particle to a thin gold foil. Okay, thin gold foil, and a circular screen is placed. Okay, and that screen is coated with zinc sulfide. Now when he conduct this experiment, he observed that observation. Now his observation was most of the alpha particle passed through the gold foil without any deflection. First observation that most of the alpha particle passed through the gold foil without any deflection. Here most of the alpha particle pass through the gold foil without any deflection. That means he is getting scintillation here. He is getting 99%, nearly 99%, okay, 99% time he is getting scintillation here. So most of the alpha particle pass through the gold foil without any deflection. Most of the alpha particle, nearly 99% alpha particle pass through the gold foil without any deflection, and it is striking just behind the screen, just behind this zinc sulfide. Okay, so he is getting 99% time he is getting scintillation just behind the gold foil. This shows that majority of the alpha particle, most of the alpha particle pass through the gold foil without any deflection. Now sometime he got deflection here. 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 One or two times he got deflection here. So his second observation that most of the alpha particle pass through the gold foil without any deflection, because majority of time he is getting scintillation just behind this gold foil. That means that alpha particle is passing through the gold foil without any deflection. Is passing through the, let this be the gold foil. Okay, let this be the gold foil, and it is passing through the gold foil without any deflection. Majority of time it is passing through the gold foil without any deflection. Now sometimes, okay, sometimes he is getting deflection here. That shows that, okay, some alpha particles undergo small angle deviation, some alpha particle undergo large angle deviation. Sometimes he is getting scintillation here and here. So here some alpha particle undergoes small angle deviation. Actually this is alpha particle, and they are undergoing small angle deviation. Sometimes they are undergoing large angle deviation, right? So second postulate, okay, few alpha particles undergo small angle and large angle deviation. Okay, some alpha particles undergo small angle deviation and some alpha particles undergo large angle deviation. Now 1 or 2 times he is getting scintillation here. That means this alpha particle is almost deviating to 180 degree, right? The alpha particle is almost deviating to 180 degree. So I am writing the third observation here. 1 or 2 alpha particle retrace the path or deviate to 180 degree. Actually these are alpha particle and they are retracing. That means they retrace the path. That means they make 180 degree deviation. So this was the observation of alpha ray scattering experiment. So Rutherford bombarded a stream of alpha particle on a thin gold foil. He bombarded a stream of alpha particle to a thin gold foil. Now this experiment was covered by a screen, and the screen is coated with zinc sulfate. Now when he done this experiment, what he was observed is that most of the alpha particle pass through the gold foil without any deflection, because 99% time he is getting deflection here, that is just behind. Okay, let this be, like, you can consider this as this point. Let this be the atom. Okay, so majority time he is getting deflection here. 1 or 2 time, like few times alpha particles are deflected towards small angle, and last few times alpha particles are deflected to large angle, and 1 or 2 times it is retracing the path. So you can consider like this, let this be the point. So we are bombarding stream of alpha particle to a point in the gold foil. Now let this be the point. This is the point. Now this is the screen. Majority time alpha particle pass through the gold foil without any deflection. That's why we are getting scintillation just behind this gold foil. Majority time alpha particle, that is 99% alpha particle, pass through the gold foil without any deflection. Let this point, I am representing this point here. Actually this is this point, this big figure is this point. Okay, we are passing gold foil through that point. Okay, let this point be this. Now majority of the alpha particle, when we pass alpha particle, is passing through the point. So that is majority of the alpha particle passing through that point. This is the point to without any deflection. Now 1 or 2 few alpha particle undergo large angle deviation, small angle deviation, and few alpha particle undergo large angle deviation, and 1 or 2 alpha particle retrace the path. Right? Few alpha particle undergo small angle deviation, few alpha particle undergo large angle deviation, and 1 or 2 alpha particle retrace the path. These are the observations of gold foil experiment. Alpha ray scattering experiment. I think it's clear. So conclusions of Rutherford after doing alpha ray scattering experiment. So observation, I think you remember the observations. What are the observations? When a stream of alpha particles pass through or bombarded with a thin gold foil, okay, he is getting majority of scintillation just behind this gold foil, right? Now if you consider this point, like, so alpha particles passing through a point in the gold foil. Let this small point, when we picturize the small point, actually majority of the alpha particle pass through this gold foil without any deflection. That's why majority of time we are getting scintillation just behind the gold foil, right? This shows that most of the space in an atom is empty. When we pass alpha rays through a thin gold foil, when we project those alpha particle in one of the point in the gold foil, okay, alpha ray penetrate, or it is passing through the gold foil. Majority of time alpha ray is passing through the gold foil without any deflection. This shows that majority of a space in an atom, majority space in an atom is empty. Majority of space in an atom is empty. If you consider an atom, majority of the space in an atom is empty, right? Now a few alpha particle, a few positively charged alpha particle was deflected. This is due to the repulsive force showing that the positive charge is not spread throughout the atom. The positive charge has to be concentrated in a very small region at the center called nucleus. Actually, when we conduct this experiment, we observe that some alpha particle undergo small angle deviation, some undergo large angle deviation, and some 1 or 2 retrace the path. Now alpha rays are actually positive charge particle. Positive charge particle. Alpha rays are actually positive charge particle. Okay, so when an alpha ray is deflecting, means it should come near a positive charge, right? Alpha rays are positive particle. Alpha rays are positive charge particle. So they are positive charge. That means when an alpha ray deflection means it should come near to a positive charge. It should come near to a positive charge. Then only an alpha particle will deviate. Alpha rays are positive charge. They are alpha rays are positive charge. So they are deflecting means they should come near to a positive charge, right? They should come near to a positive charge. So a few positive charge alpha particles are deflected. This is due to a repulsive force showing that the positive charge is not spread throughout the atom. The positive charge has to be concentrated in a small volume at the center of the atom. So this shows that due to this deflection, we can say that there is a small positive charge at the center of the atom. This positive charge is known as nucleus. This positive charge is known as nucleus. So he introduced for the first time, he introduced nucleus for the first time. He is the one who introduced nucleus, the term nucleus, for the first time. So there is a small positive charge at the center of the atom. As a result of this positive charge, when an alpha particle come near to this positive center, they are deflecting. Okay, now again, so they are deflecting to small angle. When they come little bit closer, they will deflect to large angle, and if they come directly to nucleus, they will retrace the path. Okay, I think it's clear. So there is a small positive charge at the center of the atom. That positive charge is known as nucleus. Now calculation by Rutherford shows that volume occupied by the nucleus is negligible as compared to volume occupied by the atom. Compared to total volume of the atom, volume of nucleus is very small. The radius of atom is about 10 raised to minus 10 meter, and radius of nucleus is only about 10 raised to minus 15. This is the size difference. Radius of atom is 10 raised to minus 10 meter. If the radius of atom, that is nucleus to the outermost shell, if the radius of atom is 10 raised to minus 10 meter, then the radius of nucleus is nearly 10 raised to minus 15 meter. So nucleus is that much small. These are the conclusions of alpha ray scattering experiment. Most of the alpha particle pass through the gold foil without any deflection. That shows that most of the space in an atom is empty. Now few alpha particles are deflected through to small angles, large angles, and 1 or 2 retrace the path. Alpha rays are actually positive charge. So they are deflecting means they should come near to a positive charge. Then only they will deflect due to repulsion, right? Alpha rays are positive charge particle. They are deflected means they should come near to a positive charge, right? So there is a small positive charge. Why is small positive charge? Because the number of alpha ray deflecting, the number of alpha rays deflecting is very less. That means the size of the nucleus is very small. Okay, if the size is very big, then so many nucleus, for example, if size is very big, if size of the nucleus, majority of alpha particle will be deflected. Majority of the alpha particle will be deflected, but majority of alpha particle pass through the atom without any deflection. Majority of the alpha particle pass through the atom without any deflection means then the size of nucleus is very small. So alpha ray will pass through the atom without any deflection. But if size of nucleus is large, then majority will be deflected. Here Majority is passing through the gold foil without any deflection. That means size of the nucleus is very small. Now, the size difference between atom and nucleus. If the radius of atom is 10 raised to minus 10 meters, then the nucleus, radius of the nucleus is only 10 raised to minus 15 meter. So these are the conclusions of Rutherford models. Alpha ray scattering experiment. These are the conclusions of alpha ray scattering experiment. I think it's clear. Moving on to next topic, that is Rutherford atomic model. Now, from alpha ray scattering experiment, from the observation and conclusions from alpha ray scattering experiment, Rutherford proposed a model. That model is Rutherford's atomic model. Now, Rutherford atomic model consists of 4 postulates. First postulate is the positive charge and most of the mass of an atom was concentrated in an extremely small region at the center of the atom called nucleus. So, all the positive charge and mass of an atom, all the positive charges, that is protons, and mass is concentrated at the very small, at the extremely small region at the center of the atom. In an extremely small region at the center of the atom, this is known as nucleus. Electrons move around the nucleus at very high speed, in a circular path called orbit in these empty spaces. We know that most of the space in an atom is empty. Now, electron rotates around the nucleus at very high speed. Electron move around the nucleus with very high speed in the circular path called orbit in the empty spaces. So in these empty spaces, electron move around the nucleus with very high speed in circular path called orbits. Now, the electrons and the nucleus are held together by electrostatic force of attraction. Here, nucleus is having positive charge and electron is having negative charge. The force of attraction between electron and nucleus, positive charge, is electrostatic force of attraction. Third postulate. The number of electron is equal to number of proton. The number of proton present in the nucleus and number of electron which rotate around the nucleus are always equal. So these are the 4 postulates of Rutherford model. So first postulate, most of the positive charge and most of the mass of the atom was concentrated in a very small region at the center, and that center is known as nucleus. And electrons move around the nucleus. Electrons rotate around the nucleus with very high speed in the empty spaces. Okay, I think it's clear. Now, third one, electrons and the nucleus are held together by electrostatic force of attraction. So the protons present in the nucleus and electrons in the orbit are held together by electrostatic force of attraction. And last and final postulate, the number of proton present in the nucleus and number of electron in each orbits, that is number of electron in the atom, are equal. Always number of protons and electrons are equal. These are the 4 postulates of Rutherford model. I think it's clear. Now I'll write one more equation. Okay, formula to calculate. I'll write one more thing, that is formula to calculate radius of atom. Formula to calculate radius of atom. I'll write one more thing, that is a formula to calculate radius of the nucleus. Radius of the nucleus. Formula to calculate radius of the nucleus. And equation is R is equal to R0 raised to R0 into A raised to R is equal to R0 into A raised to 1 by 3. R is equal to R0 into A raised to 1 by 3. R is equal to R0 into A raised to 1 by 3. Now what is R? R is radius of nucleus. A is mass number and A is mass number, and R0 is a constant. Its value is 1.33 into 10 raised to minus 13 centimeter. Okay, R is radius of nucleus. A is mass number and R0 is a constant. Its value is 1.33 into 10 raised to minus 13 centimeter. R0 is a constant. Its value is 1.33 into 10 raised to minus 13 centimeter. Okay. So this is the relation between radius of nucleus and mass number. This is the relationship between radius of nucleus and mass number. Okay, usually some they may ask some problems regarding this equation. I think it's clear. So these are the postulates of Rutherford model. So atom consists of a small positive charge nucleus. All the positive charge and mass are concentrated at the center. That center region is known as nucleus, and electron rotate around the nucleus very high speed in the empty spaces. And the force of attraction between electron and proton is electrostatic force of attraction, and number of electron is equal to number of proton. I think it's clear. These are the postulates of Rutherford model. Moving on to next topic, drawbacks of Rutherford atom model. Drawbacks of Rutherford atom model. Now I'm going to point out 3 drawbacks of Rutherford model. Okay, 3 drawbacks. First drawback is inability to explain stability of atom according to Maxwell's electromagnetic theory. According to Maxwell electromagnetic theory. So first drawback is inability to explain stability of atom according to Maxwell's electromagnetic theory. Now according to James Maxwell's electromagnetic theory, James Maxwell proposed a theory. That theory is known as electromagnetic theory. Now according to electromagnetic theory, when a charged body, for example, when a charged body rotate around another charged body, for example, if a positive charged body rotate around another charged body which is opposite in charge, when a charged body rotate around another charged body having opposite charge, a positive rotate around a negative, or a negative rotate around a positive. Okay. So when a charged body rotate around another charged body, having opposite charge, okay, opposite charge, what happens is that in each rotation, this charged body will lose energy. It will lose energy. In each turn, it will lose energy. And it will finally collide with the central charge body. This is Maxwell's electromagnetic theory. When a charged body rotate around another charged body having opposite charge, the rotating charge body will lose energy, electromagnetic radiation. The rotating charge body will lose, or they will release electromagnetic radiation, okay, in each turn, and then finally it will collide with the central charge body. This is Maxwell's electromagnetic theory. When a charge body rotate around another charge body having opposite charge, both of them are opposite in charge, the rotating charge body will lose electromagnetic radiation in each turn, in each rotation, and finally it will collide with the central charge body. This is Maxwell's electromagnetic theory. Now when we apply this electromagnetic theory to Rutherford model, according to Rutherford model, electrons rotate around protons, right? Electron rotate around protons in circular path called orbits, right? Now when we apply this theory here, what happened? Actually, when we apply this theory is right. So when we apply this theory here, when a charge body rotate around another charge body having opposite charge, electron is having negative charge and proton is having positive charge. So when an electron, negative charge electron rotate around positive charge proton, okay, it will lose energy in the form of electromagnetic radiation. In each turn, it will finally collide with the central. It should finally collide with the central charge body, right? Okay, according to Maxwell's electromagnetic theory, when a charge body rotate around another charge body having opposite charge, the rotating charge body will lose electromagnetic radiation in each turn, and it finally collide with the central charge body. Now, when we apply electromagnetic theory to Rutherford model, the model is having no stability. The model is not having any stability. The model is not having stability because when this electron collide with the central proton nucleus, the atom is not stable. Atom is unstable, right? When the electron collide with the central positive charge, the atom is collapsing. That means the atom is not having any stability, right? So according to Maxwell electromagnetic theory, Rutherford model does not have any stability. Okay, What is Maxwell's electromagnetic theory? When a charged body rotates around another charged body having opposite charge, the rotating charged body will lose energy in each turn and it will finally collide with the central charged body. Now we can apply the same theory to Rutherford model. If this is actually the actual atom model, if this is the actual atom model, we don't know whether it's actual real atom model. Okay, now if this is the actual atom model, okay, then the model is not having any stability, because when we apply this theory to here, there is a positive charge and a negative charge electron is rotating around the nucleus. So obviously, according to Maxwell theory, the rotating electron will lose electromagnetic radiation. It will finally collide with the central charge body. So atom is not stable. So if this is the actual state, if this is the actual structure of atom, then the atom is not having any stability, right? That means this is not the actual structure of atom, because atom is highly stable. If this is the atom, then it is not having any stability. That means this is not the exact real structure of atom. So inability to explain stability of atom. I think it's clear. This is the first drawback of Rutherford model. Now second drawback, unable to explain electronic configuration. Unable to explain electronic configuration. Second drawback, unable to explain electronic configuration. Second drawback, unable to explain electronic configuration. Explain electronic configuration. Unable to explain electronic configuration. Now we know that if we consider the atom, first shell contain 2 electrons, second shell contain 8 electron, third shell 8 electron, right? Up to 18 electron, we can place up to 18 electron. So we can place up to 18 electron. So 2, 8, 18, 32, etc. We know the electronic configuration of each and every atom, right? But at the time of Rutherford, actually we know this configuration because we know Bohr model. Bohr model is the one who proposed or who helped us to find the electronic configuration of an atom. Bohr model helped us to find the electronic configuration of the atom. That is next model. But in the time of Rutherford, here in this time period, Rutherford was not able to find the electronic configuration of an atom. Okay, next model, that is Bohr model. We know Bohr model, that's why we know the electronic configuration. First shell contain 2 electrons, second shell contain 8 electrons, third shell contain 18 electrons. Actually, electronic configuration was explained by Bohr, by using Bohr model. At the time of Rutherford, he don't know the electronic configuration of any atom. Okay, so unable to explain electronic configuration of atom. I think it's clear. Now moving on to last point or drawback. Okay, unable to explain line spectrum of hydrogen. Line spectrum of hydrogen. Line spectrum of hydrogen. That I will explain later. Actually, we have to study this in detail in Bohr model, so that I will explain later. So these are the drawbacks of Rutherford model. First drawback, inability to explain stability of atom. According to James Maxwell, when a charged body rotates around another charged body having opposite charge, the rotating charged body will lose energy in each turn and it will collide with the central charged body. Now when we apply this model to Rutherford, when we apply this idea to Rutherford model consists of a small positive charge nucleus and electrons are rotating around the nucleus. When we apply this theory, the electron should lose energy in each turn and it will collide with the central charged body. But atom is stable. Actually, atom is stable. That means Rutherford's model is wrong. That is not the exact atom model. So according to Rutherford model, atom is not having stability. But atom is actually real, atom is stable. That means Rutherford model is wrong. That is the first drawback. And second drawback, unable to explain electronic configuration. At the time of Rutherford, he don't know the exact electronic configuration of atom. Unable to explain line spectrum of hydrogen. That I will discuss when we take Bohr theory. I think it's clear. These are the drawbacks of Rutherford model. Moving on to next topic, that is Bohr model. So Bohr model. Now after Rutherford model, The next model is Bohr model, and Rutherford proposed this model in the year 1911. After 2 years, in the year 1913, Bohr proposed this model. Okay, Rutherford proposed this model in the year 1911 by conducting a set of experiments known as alpha ray scattering experiments. After that, after 2 years, that is from 1912 and 1913, Niels Bohr proposed this model. Now, Niels Bohr proposed this model after understanding so many results which was discovered in the year 1912. So in the year 1912, so many discoveries, so many explanations were done, and using those explanations, Niels Bohr proposed a new model in the year 1913. So I'll explain once more. Rutherford model was proposed in the year 1911, but we know that Rutherford model is a failure. There are so many drawbacks for Rutherford model. After that, 2 years later, that is 1912, 1913. 1930, Bohr proposed this model, Bohr model. Now, within these 2 years, that is 1912 and 1930, so many scientific explanations were given for so many experiments. So many scientific explanations were given for so many experiments. And from using those explanations, Bohr proposed this model. Using those explanations, Bohr proposed his model. So first, before discussing about Bohr model, we have to study the development leading to the Bohr model. What all things happened in the year 1912 which leads to the formation of Bohr model. So we have to study the experimental results that was conducted in the year 1912, and from that idea, new model, Bohr model is created. Bohr model of atom is created. Okay, I think it's clear. So 1911, Rutherford model was proposed, but model contains so many drawbacks. So after 2 years, in 1913, Niels Bohr proposed a model. That model is known as Bohr model, and he got the ideas of Bohr model from the results of some scientific experiments that was conducted in the year 1912. So we have to discuss, before discussing Bohr model, we have to discuss those scientific ideas which was conducted in the year 1912. So development leading to Bohr model. Okay, now I will discuss all the phenomena which was explained in the year 1912. All those experiments which was discussed or which was explained in the year 1912. First of them is black body radiation problem. First one is black body radiation problem. Black body radiation problem. So black body, actually this black body radiation problem was first discovered in the year 1879. Actually this was discovered in the year 1879, black body radiation problem. Now actually what is black body radiation problem? Black body radiation problem is a black body is a perfect, black body is a black color metallic sphere. It's a black color metallic sphere. Black body is a black color metallic sphere. It will absorb all the radiation falling on it. It will absorb all the radiation falling on it, and it will emit all the radiations. It will absorb and emit all the radiation. A perfect black body is a black color metallic sphere. A perfect black body is a black color metallic sphere. It is a perfect absorber and emitter of radiation. It will absorb or emit radiation. A perfect black body, a black body is a black color metallic sphere. Okay, a perfect black body is a good absorber and emitter of radiation. Okay, so when light radiation falls on black body, it will absorb or emit radiation. Okay, now what is the peculiarity of this black body? At a lower temperature, let the temperature be T1. At a lower temperature, when you heat this black body, it will emit red color. Again, when you increase the temperature, let the temperature be T2. It will emit orange color. Again, when you increase the temperature, it will emit yellow color. Again, when you increase the temperature, it will emit white color. Okay, This is black body radiation problem. So a black body is a perfect absorber and emitter of radiation. A black body is a perfect absorber and emitter of radiation. Okay, it will absorb all the radiation falling on it. It will absorb all the radiation falling on it, and it will emit all the radiation falling on it. Okay, now when a black body is heated at a lower temperature, it will first emit red color. At a lower temperature, red color, it will show red color. This body will, the black body will changes to red color, or it will emit red color. With increase in temperature, it will show orange. Again increase in temperature, it will show yellow. Again increase in temperature, it will show white color. This is black body radiation problem. Actually, this was observed in the year 1879. Black body radiation problem was discovered in the year 1879. Okay, so what is a black body? A black body is a black color metallic sphere. It will absorb all the radiation falling on it, and it will emit all the radiation. It will emit all the radiation. But at a temperature, when you heat a black body at a lower temperature, let the temperature be T1. At a lower temperature, it will emit red color. That means this black body will have red color. Emit red color means it will changes to red color. Okay, with again increase in temperature, it color changes. Black color of black body changes to orange. That means it will emit orange color. That's why it's changing orange color. So it changes to orange color. Again, when you increase temperature, it will changes to yellow color. With again increase in temperature, it will changes to white color. This is black body radiation problem. So this was not explained from 1879. This is the explanation for this phenomena is not explained by anyone. The explanation is not given by anyone. From 1879 onwards, no one explained this phenomenon. Nobody is knowing what is the reason for this color change. At the lower temperature, the black body is having red color. With increase in temperature, it will emit orange. Again increase in temperature, yellow. Again increase in temperature, white color. This is black body radiation problem. Now the second problem was photoelectric effect. The next problem faced by the scientists were photoelectric effect. Now photoelectric effect. The next problem was photoelectric effect. Now what is photoelectric effect? Photoelectric effect. Photoelectric effect means when a light of suitable frequency strikes on a metal surface, electrons are ejected from the metal surface. When a light of suitable frequency strikes on metal surface, electrons are ejected from metal surface. This phenomena is known as photoelectric effect. Okay. This also, the explanation for this phenomena is also not explained at that time. When a light of suitable frequency strikes on a metal surface, electrons are ejected from the metal surface. This is the second phenomena, and this phenomena is also not explained at that time. Okay, so these are the two phenomena. You have to remember these two phenomena. First one is black body radiation problem, and second one is photoelectric effect. First one is black body radiation problem, and second one is photoelectric effect. And these two problems are explained by Planck's quantum theory, which we will discuss later. These two problems are explained by using Planck's quantum theory, which we will discuss later. So these are the two big problems faced by the science at that time. Okay, first one is black body radiation problem, and second one is photoelectric effect. I'll explain once more. Rutherford model was proposed in the year 1911. After 2 years, in the year 1913, Bohr model was proposed. We know that Rutherford model have some drawbacks. Okay, so after 2 years, 1913, Bohr model was proposed, and Bohr proposed this model after gaining some ideas of some scientific experiment which was explained in the year 1912. So Bohr proposed this model, okay, from those scientific ideas which he gathered in the year 1912. So what are the scientific ideas he gathered in the year 1912? Bohr, okay, gathered in the year 1912. The first one is black body radiation problem. Actually, black body was first observed. This black body radiation problem was first observed in the year 1879. Now, black body is a perfect absorber. A black body is a black color metallic sphere. It will absorb all the radiation. It's a perfect absorber and a perfect emitter. Now, when you heat a black body at a lower temperature, it will show red color. It will emit red color. With increase in temperature, it will show orange or it will emit orange color. With again increase in temperature, it will show yellow or emit yellow color. With again increase in temperature, it will show white color or emit white color. This is black body radiation problem. Okay. Now second one is photoelectric effect. When light of suitable frequency strikes on metal surface, electrons were ejected from metal surface. These are the two problems, or these are the two scientific problems which was not explained during that time. These problems are explained by using Planck's quantum theory, which we studied in detail. Next topic is actually Planck's quantum theory. I think it's clear. Now after Planck's quantum theory, when Planck proposed Planck's quantum theory, from Planck's quantum theory, Bohr proposed this model. By using ideas from Planck's quantum theory, he proposed this model. Okay, so to explain this, Planck proposed Planck quantum theory. From Planck quantum theory, Bohr proposed this model. From the ideas of Planck's quantum theory, he proposed this model. So next topic is actually Planck's quantum theory. I think it's clear. These are the two scientific problems faced by those scientists at that time. So moving on to next topic. Now, the two important problems which scientists faced at that time were black body radiation problem and photoelectric effect. Right? And these two problems are explained using Planck's quantum theory. Next topic is actually Planck's quantum theory. But before studying about Planck's quantum theory, we should get some ideas about light. My first question, what type of nature does light possess? Is it a wave nature? Is it wave or particle? What type of nature light possess? Wave nature or particle nature? According to Newton, he says that light consists of streams of particle. Light is actually having particle nature. According to Newton, light are particles in nature. They are light consists of stream of particle. Light consists of stream of particle. This is what Newton proposed. Light consists of stream of particle, and he called these light particles as corpuscles. Corpuscles, C-R-O-U-P-S, C-R-O-U-P-S-C-E-L-S, corpuscles. Okay, corpuscles. So Newton was the first one who first tell about the nature of light. He proposed that light consists of stream of particles, and those particles he called them as corpuscles. But later, okay, by using particle nature, we can explain reflection, refraction, etc. By considering light as a particle, we can explain reflection, refraction, etc. If, for example, if I'm this top is a particle. When I throw this top onto a wall, the top will hit and return back. For example, I'm throwing this top on this board. Now it's returning back, right? So it's a particle nature. Particle is having reflection property. We know that light is having reflection property. That means light is a particle. Okay, so reflection, refraction property, some properties of light like reflection, refraction, etc. are considering light as particle. Okay, now later Christian Huygens, I think you remember that name. Christian Huygens proved that light consists of wave nature. Light possesses wave nature. Later Christian Huygens shows that light possesses wave nature. By using wave nature of light, we are explaining diffraction, interference, etc. Okay, so some of the properties of light shows light consists of particle nature, and some of the property of light shows light consists of wave nature. Reflection, refraction, etc. shows. So reflection, refraction, etc. shows particle nature of light, and the diffraction, interference shows wave nature of light. So particle nature was first proposed by Newton, and he says that light consists of stream of particles. These particles are known as corpuscles. Okay, now wave theory was proposed by Christian Huygens. Now we know that light possesses dual nature. Some properties are explained by particle nature, some properties are explained by wave nature. That means light possesses dual nature. Light possesses dual nature. Okay, light show dual nature. That means light always travel in the form of wave, and they contain particles. They possess particle nature. So light possesses wave nature as well as particle nature. They possess wave nature as well as particle nature. Okay, I think it's clear. So light possesses dual nature. They show wave nature and they show particle nature. Wave nature of light was first proposed by Christian Huygens, and particle nature was first proposed by Christian Huygens. Wave nature was first proposed by Christian Huygens and particle nature was first proposed by Newton, Sir Isaac Newton. Now, initially we thought that, okay, now, next is, light is an electromagnetic radiation. Light is an electromagnetic radiation. Now, what are electromagnetic radiation? Light is an electromagnetic radiation. Light is an electromagnetic radiation. Light is an electromagnetic radiation. Now, what does actually electromagnetic radiation means? Electromagnetic radiation means electromagnetic radiation. Electromagnetic radiation means radiation associated with electric and magnetic field perpendicular to each other and also in their perpendicular to the direction of propagation. So electromagnetic radiation means radiation associated with electric and magnetic field, radiation associated with electric and magnetic field perpendicular to each other, perpendicular to radiation associated with electric and magnetic field perpendicular to each other and perpendicular to the direction of propagation. So radiation associated with electric and magnetic field perpendicular to each other and perpendicular to the direction of propagation. Now what is the meaning of this? I'll show you a figure in textbook. I'll show you a figure in the textbook. Now in page number 137, they have given a figure. Now if you see this figure, you can see that light is propagating in the x-axis, light is propagating in x-axis, and red line corresponding to electric field and blue lines corresponding to magnetic field. Red line corresponding to electric field and blue line corresponding to magnetic field. So light propagating in x-axis, electric field is propagating in y-axis and magnetic field is propagating in z-axis. Right, light is propagating. If light is propagating, light is a wave, it propagates in x-axis. If light propagates in x-axis, perpendicular to propagation of light, that is in y-axis, electric field propagate with light. Light propagates in x-axis along with in the propagation. Light propagates in the x-axis, perpendicular to x-axis, that is y-axis. In y-axis, electric field propagate with light. In z-axis, magnetic field will propagate with light. So light propagating in z-axis, we can draw like this. Light propagate in z-axis. Okay, in y-axis, electric field is propagating in y-axis along with the propagation of light, and in the z-axis, magnetic field is propagating. Okay. These radiations are known as electromagnetic radiation. So when a radiation propagates, in perpendicular directions, if electric and magnetic field are associated with the radiation, then those radiations are known as electromagnetic radiation. Radiation associated with electric and magnetic field perpendicular to each other and the perpendicular to the direction of propagation. If a radiation is propagating in x-axis, if in y-axis, if electric field is propagating with that radiation, and in z-axis, if magnetic field is propagating with the radiation, then those radiations are known as electromagnetic radiation. Light radiation is an electromagnetic radiation because if light radiation propagates in x-axis, along in y and z-axis, electric and magnetic field will propagate along with the light. So we can say that light is an electromagnetic radiation. So what are electromagnetic radiation? Radiation associated with electric field and magnetic field perpendicular to each other, and they are perpendicular to the direction of propagation. I think it's clear. So initially we thought that light is the only electromagnetic radiation. Light is the visible light. Violet, indigo, blue, green, yellow, orange, red. They are the only electromagnetic radiation. But later we come to know that not only light, there are so many electromagnetic radiation. Not only light, there are so many other electromagnetic radiation. Initially we thought that light is the only electromagnetic radiation. I think electromagnetic is clear. If a radiation is propagating along in x-axis, in y-axis, electric field is propagating with that radiation, and in z-axis, magnetic field is propagating with that radiation, then those radiations are known as electromagnetic radiation. Initially we thought that light is the only electromagnetic radiation, but later we came to know that not only light, there are other electromagnetic radiation. There are so many other electromagnetic radiation. Okay, they are gamma rays, X-rays, ultraviolet rays, visible, normal visible light, infrared, microwave, radio wave. All these are electromagnetic radiation. Initially we thought only visible light is the electromagnetic radiation. Then we came to know that there are other electromagnetic radiation. They are gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio wave. These are electromagnetic radiation. Now the peculiarities of electromagnetic radiations are all of them travel with the same speed, 3 into 10 raised to 8 meter per second. All electromagnetic radiation, that is X-ray, gamma ray, ultraviolet, visible, infrared, microwave, radio wave, all electromagnetic radiation travels with the same speed, that is 3 into 10 raised to 8 meter per second. That is the importance of electromagnetic radiation. All of them. Initially we thought light was the only electromagnetic radiation. Then we came to know that there are some other electromagnetic radiations. Okay, these are the other electromagnetic radiation, and all the electromagnetic radiation travels with the same speed, that is 3 into 10 raised to 8 meter per second. I think it's clear. Now, arrangement of electromagnetic radiation in the increasing order of, arrangement of electromagnetic radiation in the increasing order of wavelength or decreasing order of frequency. Arrangement of electromagnetic radiation in the increasing order of wavelength or decreasing order of frequency. This spectrum is known, this arrangement is known as electromagnetic spectrum. Electromagnetic spectrum. So there are so many electromagnetic radiation. Arrangement of electromagnetic radiation in the increasing order of wavelength or decreasing order of frequency. That spectrum is known as electromagnetic radiation. Okay, now before discussing this in detail, first tell me what is wavelength, what is frequency, etc. What is wavelength, what is frequency? So before discussing this topic, before discussing in detail about this topic in detail, tell me what is wavelength, what is frequency, etc. What is wavelength? Okay, I will explain that one. Then after that we can move to electromagnetic spectrum. So what are wavelength? Now all electromagnetic radiation travels in the form of transverse wave. All electromagnetic radiation, all electromagnetic radiations travels in transverse waveform. Transverse wave. All electromagnetic radiations are transverse wave. Transverse wave. What are transverse wave? Transverse wave means these waves are known as transverse wave. These waves are known as transverse wave. All electromagnetic radiation travels in the form of transverse wave. They always travels in the form of transverse wave. The properties of transverse waves are wavelength, frequency, etc. Properties of transverse, I'll explain that. Okay, so arrangement of electromagnetic spectrum in the increasing order of their wavelength or decreasing order of their frequency is known as electromagnetic spectrum. Before studying in details about electromagnetic spectrum, first we can study about transverse wave. All our electromagnetic radiation, X-ray, gamma ray, ultraviolet, visible, infrared, microwave, radio wave, all electromagnetic radiation travel in the form of transverse wave. Transverse wave. Now the transverse waves have crust. Top part is known as crust and down parts are known as trough. They are known as crust and trough. Up parts are known as crust and down parts are known as trough. Okay, all transverse waves have crust and troughs. Okay, now these wavelength, frequency, etc. are properties of transverse wave. So I'll discuss that one. Properties of transverse. So next topic is properties of transverse wave. Properties of transverse wave. Properties of transverse wave. Properties of transverse. First one, wavelength, represented by lambda. Now what is wavelength? Wavelength means it is the distance between two consecutive trough or two consecutive crust. It is the distance between two consecutive crust or two consecutive trough. This is known as wavelength. It is the distance between two consecutive crust or two consecutive trough. This is known as wavelength. Okay, this is wavelength. So what is wavelength? It is the distance between two consecutive crust or two consecutive trough. That is lambda, wavelength. This is the first property of transverse wave. Properties of transverse wave. First property is wavelength. What is wavelength? It is the distance between two consecutive crust or two consecutive trough. This is the first property of transverse wave, wavelength. Now second one is frequency. What is frequency? Frequency, it is represented by, frequency is represented by nu. Frequency, it is represented by nu. Represented by nu. Now frequency means it is the number of waves passing through a point per second. It is the number of waves passing through a point per second. In 1 second, how many waves are passing through this point? That is frequency. It is the number of waves passing through a point per second. So consider a point here. Consider a point here. In 1 second, how many waves are passing through this point? That is known as frequency. Number of waves passing through a point per second. That is frequency. Okay, so what is wavelength? Distance between two consecutive crust or two consecutive trough is known as wavelength. What is frequency? Number of waves passing through a point per second in 1 second. That is frequency. Now this frequency and wavelength are related like this. Frequency and wavelength are inversely proportional. Frequency inversely proportional to wavelength. So nu is equal to, I multiply, removing proportionality by multiplying with a constant c by lambda. Nu is inversely proportional to wavelength. Nu is inversely proportional to wavelength. Nu is equal to c by lambda. C is constant velocity of light. Okay, they are inversely proportional. Frequency and wavelength are inversely proportional. Now I think what is, you know what is wavelength and frequency. What is wavelength? Wavelength means distance between two consecutive crust or two consecutive trough. This is wavelength. Now what is frequency? Number of waves passing through a point. Number of waves passing through a point per second. Okay, their frequency and wavelength are inversely proportional. Nu proportional to 1 by lambda, or nu inversely proportional to lambda. Removing proportionality, multiplying with a constant, nu is equal to c by lambda. I think it's clear. C is velocity of light. This is the equation between nu, lambda and c. Nu is equal to c by lambda. Frequency is equal to velocity of light by wavelength, c by lambda. I think it's clear. Now next is wave number. Next property is wave number. What is wave number? Wave number means it's reciprocal of wavelength. Wave number. Wave number. Wave number is represented by nu bar. Nu bar. Reciprocal of wavelength. It is the reciprocal of wavelength. Reciprocal of wavelength is known as wave number. These are the properties of transverse wave. Wavelength, frequency, wave number, velocity is also there. What is velocity? Distance travel divided by time. That you know what is velocity. Velocity means, next property is velocity. Velocity, what is velocity? Distance or displacement by time. So distance traveled by the wave. In the case of wave, distance traveled by the wave per time. Distance traveled by the wave by time. That is velocity of wave. That you know what is velocity. Same equation. So these are the four important properties of transverse wave. All electromagnetic radiation. Light is an electromagnetic radiation. Then these are all electromagnetic radiation. Electromagnetic radiations always travel in the form of transverse wave. For transverse wave, these are the properties. They have wavelength, frequency, wave number, velocity, etc. Wavelength, the distance between two consecutive crust or trough. Frequency, number of waves passing through a point per second. Wavelength and frequency are related by nu is equal to c by lambda. Now wave number is reciprocal of wavelength. Nu bar is equal to 1 by lambda. Velocity, distance traveled by the wave per second. Per time. Time in second. Okay, time is expressed in second. SI unit is second. These are the properties of transverse wave. Now, electromagnetic radiation. Now, arrangement of electromagnetic radiation in the increasing order of frequency. Now, which radiation is having maximum, in the increasing order of wavelength, which is having maximum wavelength? Radio wave is having maximum wavelength, because increasing order of wavelength. Radio wave is having maximum wavelength, and minimum wavelength is for gamma ray. Gamma ray is having minimum wavelength. Okay. Now we know that wavelength is inversely proportional to frequency. So radio is having minimum frequency and X-ray, gamma rays are having maximum frequency, because wavelength and frequency are inversely proportional. So that's why we are writing like this: increasing order of wavelength or decreasing order of frequency. Radio is having maximum wavelength, minimum frequency. Decreasing order of frequency. So arrangement of electromagnetic radiation in the increasing order of their wavelength, or wavelength maximum for radio wave, so frequency is minimum for radio wave, or you can increasing order of wavelength or decreasing order of frequency. Frequency is minimum for radio wave. This is known as electromagnetic spectrum. I think it's clear. Moving on to next topic, Planck's quantum theory. Moving on to next topic, that is Planck's quantum theory. Now, Planck's quantum theory, this theory was proposed by Max Planck, and this theory consists of three postulates. Planck's quantum theory was proposed by Max Planck, and this theory consists of three postulates, 1, 2 and 3. Now, according to first postulate of Planck's quantum theory, radiant energy absorbed or emitted by bodies are not continuous but discontinuous in the form of small packets of energy. These energy packets are called quanta or quantum. In the case of light, they are known as photons. So radiant energy absorbed or emitted, not continuously but discontinuously in the form of small packets of energy. Those energy packets are known as quanta or quantum. Suppose consider two bodies, A body and a B body. Let this A body be a hot body and let this B body be a cold body. Now when you place these two bodies nearby, when you place this cold body near to a hot body, obviously you can see energy flow from hot body to cold body. When you place a cold body near to a hot body, energy will flow from hot body to cold body. Okay, I think it's clear till here. Energy will flow from hot body to cold body. Now, according to Planck's quantum theory, energy absorbed or emitted by bodies are not continuously. A body, that hot body, will not continuously give energy to cold body. Energy is not emitted or absorbed continuously. Energy is not emitted or absorbed continuously. Actually, emitted and absorbed energies are packets. So energy absorbed and emitted are not continuously, discontinuously in the form of small packets of energy. These energy packets are called quanta or quantum. Quanta, or quantum. A radiant energy absorbed or emitted, not continuously. Energy is not continuously given from one body or transferred from one body to another body. Okay, energy is not transferred from one body to another body continuously. Okay, energy is transferred discontinuously in the form of small packets of energy. These energy packets are known as quanta or quantum. So when you place a hot body near to a cold body, energy is transferred from hot body to cold body, and that energy is not transferred continuously. It is transferred discontinuously in the form of small packets of energy. These energy packets are known as quanta or quantum. Now in the case of light is also a form of energy. You know that, right? Light also consists of light. Light is also a form of energy, right? Light consists of energy packets. Light is a form of energy, so they contain energy packets. In the case of light, energy packets are known as photon. In the case of light, energy packets are known as photon. In the case of light, it is known as photon. So energy absorbed or emitted is not continuously, it is discontinuously in the form of small packets of energy. These energy packets are known as quanta or quantum. In the case of light, those energy packets are known as photon. This is the first postulate. Now second postulate, energy associated with each packet is directly proportional to frequency of the radiation. Now energy of each packet, if you consider one packet, let us consider one packet. Energy of each packet, energy of each packet is directly proportional to its frequency. Energy associated with each packet is directly proportional to its frequency of the radiation. Energy associated with each packet is directly proportional to frequency of the radiation. E is directly proportional to nu. Nu is frequency. Nu means E means energy and nu means frequency. So E is directly proportional to frequency. E is equal to, I'm removing proportionality, okay, by multiplying with a constant. So E is equal to h nu. H is known as Planck's constant. I'm removing proportionality by multiplying with a constant. So E is equal to, okay, h nu. E is equal to h nu. E is directly proportional to nu. Removing proportionality, instead of proportionality, I'm giving equal. I'm writing equal and multiplying with a constant. So E is equal to h nu. H is known as Planck's constant. Its value is 6.626 into 10 raised to minus 34 joule second. Okay, joule second. This is the second postulate. So energy associated with each packet is directly proportional to frequency. E is directly proportional to nu. E is equal to h nu. H is known as Planck's constant. Its value is 6.626 into 10 raised to minus 34 joule second. Moving on to last postulate. Energy is an integral multiple of h nu. Energy is an integral multiple of h nu. N can have value. That is E is equal to nh nu. N is equal to 1, 2, 3, 4, etc. Energy is an integral multiple of h nu. Energy is an integral multiple of h nu. That is E is equal to nh nu. N can have value 1, 2, 3, 4, etc. E is equal to nh nu and energy can have value 1, 2, 3, etc. Now what is the meaning of this postulate? Now here in this postulate, if you consider, like in this postulate, they have given that a body can transfer energy. For example, if you consider a hot body A and a cold body B. Okay, when N value is equal to 1, then E to become E is equal to h nu. That means a body is donating only one packet of energy. If N value is 1, E is equal to h nu. H nu is the energy of a single packet. H nu is the E is equal to h nu is the energy of a single packet, right? So if N value is equal to 1, A is donating a single packet of energy to B. Now if N value is equal to 2, then we will get E is equal. That means here A is giving 2 packets. A is giving 2 packets, h nu plus h nu. When N is equal to 2, E is equal to 2 h nu. N value is equal to 2 means E is equal to 2 h nu. That means h nu plus h nu, 2 packets. Now N value is equal to 3. If N value is equal to 3, then E is equal to 3 h nu. That means h nu plus h nu plus h nu is supplying 3 packets. Okay, So that is E is equal to NH nu. A body will emit or a body will absorb energy packets in a whole number ratio, in a whole number. That means it will absorb one packet, it can absorb two packet, it can absorb three packet, but it will not absorb half packet, 3/4 packet, 1/4 packet. That is, fractional packets are not absorbed or emitted. A complete packet is emitted. A complete packet is emitted or absorbed by a body. Half packet, 3/4 packet, 1/4 packets are not absorbed or emitted. Energy is an integral multiple of h nu. E is equal to NH nu. N value is 1, 2, 3, 4. If N value is 1, one packet is absorbed or emitted. N value is 2, two packets of energy, two energy packets are absorbed or emitted. N value 3, three packets of energy are absorbed or emitted. I think it's clear. Half packet, 3/4 packet, 1/4 packets of energy are not absorbed or emitted. Okay, whole number value, single one packet, two packet, three packet, whole packet is absorbed or emitted. No half packet. Okay, we cannot cleave the packet. They won't cleave the packet. So energy is an integral multiple of h nu. E is equal to h nu. N can have value 1, 2, 3, 4. If N value is 1, one packet. N value 2, 2 h nu. That is h nu plus h nu. Two packets. N value is equal to 3, 3 h nu. H nu plus h nu plus h nu. Okay, half packet, fractional packets. Half, 3/4, etc. That is, they are fractional. Fractional packets are not absorbed. Only whole number value packets, that is 1, 2, 3, 4, etc. packets are absorbed. I think it's clear. These are the three postulates of Planck's quantum theory. So moving on to next topic, that is photoelectric effect. Now, photoelectric effect was first observed by Ncert. Photoelectric effect was first observed by Ncert when Ncert conducted an experiment. So I will explain the experiment conducted by Ncert and its observation conclusions later. Okay, first I will explain what is photoelectric effect. This effect was first observed by Ncert. Okay, now what is this phenomena? Photoelectric effect means when a light of suitable radiation, when light of suitable frequency or energy, strikes on, when light of suitable frequency or energy strikes on metal surface, when light of suitable frequency or energy or strikes on metal surface, electrons are ejected from the metal surface. This phenomena is known as photoelectric effect. When light of suitable frequency or energy strikes on metal surface, electrons are ejected from metal surface. This phenomena is known as photoelectric effect. Okay, I think it's clear. When light of suitable frequency strikes on metal surface, electrons present on the metal surface are ejected. Electrons present in the metal surface are ejected. Okay, this phenomenon is known as photoelectric effect, and this phenomenon was first observed by Ncert. But he could not explain why this phenomenon is occurring. When light strikes on metal surface, like cesium metal, for example, we can take cesium metal. When light strikes on cesium metal, electrons are ejected from cesium metal surface of the cesium metal. Electrons are ejected from the surface. Ncert observed this phenomena, but he could not explain the reaction or science behind this phenomena. He could not explain the science behind this phenomena. And this phenomena was explained by Einstein by considering Planck's quantum theory. This phenomena was explained, this photoelectric effect was explained by Einstein by considering Planck's quantum theory. Now, according to Einstein, light consists of energy packets. Those energy packets are known as photon. Light consists of, according to Planck quantum theory, light is a form of energy, and energy consists of energy packets. In the case of light, they are known as photon. Usually they are not quanta. In the case of light, they are known as photon. Okay, now the metal surface contain so many electrons, and these electrons are firmly attached on the metal surface. They are attached on the metal surface. The metal surface contains so many electrons on the surface, and they are actually attached. They are firmly attached on the metal surface. Now, when light falls on metal surface, lights contain energy packet. Lights are actually packets of energy. These energy packets are known as photon. When light strikes on metal surface, these light contain energy packets. They are known as photons. When this photon strikes on these electron, when the photon strikes on metal surface, by using, let the energy of photon, let the energy of each packet be h nu. Let the energy of each packet be h nu. By using some amount of energy, this is the energy packet or photon, this is the energy packet or photon. So when the photon, light packet strikes on metal surface, when the light strikes on a metal surface means actually light consists of energy packets. Light strikes means light consists of energy packets. When this energy packet strikes on metal surface, by using some amount of energy from the packet, this attraction is broken. By using some amount of energy from the energy packet, the electron and the metal surface, the bond between electron and the metal surface is cleaved. Now the electron is free. Now the remaining energy of the packet is given to the electron. So what happened? Now this electron got energy. It will move from the surface. Okay, I think it's clear. I'll explain once more. Consider cesium metal. Now in cesium metal there are so many electrons attached on the surface. Consider cesium metal. Let this be the cesium metal. And there are so many electrons on the surface of cesium metal. They are bonded on the surface of cesium metal, right? They are bonded. Now when light strikes on cesium metal surface, light consists of energy packets. Light means they are packets of energy. Light consists of energy packets, right? Now each packet is having energy h nu. According to Planck quantum theory, energy associated with each packet is equal to h nu. So each packet is having energy is equal to h nu. When this packet strikes on metal surface, some amount of energy of this packet is used to cleave the bond, the attraction between surface and the electron. Okay, now this electron is free. The remaining energy of the packet is supplied to that electron. Now the electron gain the energy, so that the electron will move from the surface. This is actually photoelectric effect. This is explained by Einstein by using Planck quantum theory. So photoelectric effect means when light strikes on metal surface, electrons are ejected from the metal surface. This was first observed by Heinrich Hertz, but he could not explain the phenomena, science behind this phenomena. And this was explained by Einstein by using Planck quantum theory. Light consists of energy packets called photon. When photon strikes on metal surface, some energy of the photon, a single photon, when a single photon strikes on metal surface, some energy of the photon is used to cleave the attraction between electron and the surface. Some amount of energy of the photon is used to cleave the attraction between electron and the surface. Okay. Now the remaining amount of energy of that photon is given to that electron. So now the electron got energy, it will emit. It got energy, so it is used to move. That energy is used to move the electron will absorb the energy, and by using that energy, it moves from that surface. Right. So we can write like this. I think it's clear. I think this point is clear. Now you can write this. You can write a relationship between h nu energy and movement energy. Like you can write a relation like this: h nu is equal to h nu 0 plus kinetic energy. Here, single photon, energy of single photon is h nu. That energy is used. Some amount of energy of that photon is used to remove an electron from metal surface. Okay, the energy required to remove that electron from that metal surface is known as threshold energy. Threshold. Threshold energy, or it is also known as work function. This is energy of incident light. Energy of incident incident light, this is the energy of incident light, that is h nu. Okay, now some amount of energy is used to remove the attraction between electron and surface, that is known as threshold energy. It is the minimum amount of energy required to remove an electron from metal surface. It is the minimum amount of energy required, that is threshold energy. It is the minimum amount of energy required to remove an electron from metal surface. So incident energy, incident photon energy, okay, incident energy of the photon is used to remove an electron from metal surface. That energy is known as threshold energy, h nu 0. The remaining energy of the photon is supplied to the electron, so electron will move from the surface. So energy required for movement is known as kinetic energy. So we can derive a relation like this: h nu is equal to h nu 0 plus half kinetic energy, or you can write like this: half mv square. Half mv square is kinetic energy of the electron. Kinetic energy of the electron. I think it's clear. I think it's clear. I think it's clear. I'll explain once more and tell me whether you can tell me if you have any doubt. You can tell me. Okay. Now here cesium metal. If you consider cesium metal, electrons are firmly bounded on the surface. Now when light strikes on metal surface, light consists of energy packets. We can consider one packet. Let the packet energy of the packet be h nu. Now some amount of energy, let the incident light energy of incident photon be h nu, energy of incident light or photon. Now some amount of energy is used to remove that electron from metal surface. That energy, the energy required to remove that electron from metal surface is known as h nu 0. It's known as threshold energy. The minimum amount of energy. What is threshold energy? It is the minimum amount of energy required to remove an electron from metal surface. That is h nu 0. So incident light, energy of incident light is used to remove an electron from metal surface. That is threshold energy or work function. It is the minimum amount of energy. This is the energy of the packet. Okay, now this much of energy is used to remove an electron from metal surface, that is known as threshold energy. And the remaining energy is given to the electron, so electron will migrate from the surface, and that energy is known as kinetic energy. So we can write h nu is equal to h nu 0 plus half mv square. And the energy of incident light is used to remove an electron from metal surface, that is threshold energy. Remaining energy is supplied to electron, so electron will move from the surface, that is kinetic energy. h nu is equal to h nu 0 plus half mv square. So what is threshold energy? It is the minimum amount of energy required to remove an electron from metal surface. I think it's clear. What is nu 0? Threshold frequency. h nu 0 is threshold energy or work function. Nu 0 is threshold frequency. This is threshold energy. Total is threshold energy. Nu 0 is known as threshold frequency. I think it's clear. This is how Einstein explained photoelectric effect by using Planck's quantum theory. I think it's clear. Now we are going to study the observations of photoelectric effect conducted by Ncert. So we are going to study about the observations of experiment conducted by Ncert. Okay. So moving on to next topic, the experiment conducted by Hertz. Now this is the experiment conducted by Hertz. Now these are his observations. So photoelectric effect was first observed by Hertz and by conducting an experiment, and these are his observation. Now this is cesium metal. So when light strikes on cesium metals, electrons are ejected from cesium metal. Electrons are ejected from each cesium metal. When this electron strikes on this detector, this is a detector. From this detector, he can read that electrons are coming. So this is how he conduct this experiment. So here this is cesium metal, and a when light strikes on cesium metal, this detector is reading the electron. The detector is reading the electron. That means electrons are ejected from the metal surface. This is how he first observed photoelectric effect. And these are his observation. Electrons are ejected from the metal surface as soon as light strikes on a metal surface. There is no time lag. When light strikes on metal surface, he is detecting electrons here. When light strikes on metal surface, he is detecting electrons here. That means there is no time lag When light strikes, suddenly electrons are ejected. There is no time lag. When light strikes on metal surface, he is detecting electrons here. The detector is detecting electron here. That means there is no time lag. Electrons are ejected from the metal surface as soon as light strikes on metal surface. There is no time lag. This is his first observation. Second observation, the number of electron ejected is directly proportional to intensity of light used. If he used high intensity light, he used high intensity light and low intensity light. Low intensity light. So the number of electrons ejected, when he used high intensity light, the number of electrons ejected is more compared to low intensity light. So when he used high intensity light, the number of electron ejected is more. But when he used low intensity light, the number of electron ejected is less. So the number of electron ejected is directly proportional to intensity of the light used. When he used high intensity light, the number of electrons ejected from the metal surface is more compared to low intensity light. When he used low intensity light, number of electron ejected is less. Second observation. And third observation, the kinetic energy of the ejected electron is directly proportional to frequency of incident light. So when he use high frequency light, incident light, the kinetic energy of the electron ejected is also more. Kinetic energy of the ejected electron is more. But when he use low frequency incident light, the ejected kinetic energy of the ejected electron is very less. So the kinetic energy of ejected electron is directly proportional to frequency of incident light. If the frequency of incident light is high, then the kinetic energy of ejected electron is also high. But when he use low frequency incident light, the ejected electron is having low kinetic energy. So these are his observations. So this is photoelectric effect. So what is photoelectric effect? When light strikes on metal surface, electrons are ejected from the metal surface. H nu is equal to H nu 0 plus half mv square. H nu is the energy of incident light. H nu 0 is known as threshold frequency or work function, plus K is kinetic energy. I think it's clear. This is photoelectric effect. So photoelectric effect was first observed by Hertz, and photoelectric effect was explained by Einstein by using Planck's quantum theory. Moving on to next topic, Bohr model for hydrogen atom. Now according to Bohr model consists of 5 postulates. Okay, Bohr model consists of 5 postulates. So I'll start with first postulate. So moving on to third model, and that model is Bohr model. Already we discussed plum pudding model proposed by Thomson, Rutherford model proposed by Rutherford, and third model Bohr model for hydrogen atom. Actually Bohr proposed model only for hydrogen atom. Okay, he took hydrogen atom and he explained the model. Okay, so that's why the heading is Bohr model for hydrogen atom, because he proposed a model for hydrogen atom, not for other atom. He proposed a model only for hydrogen atom. Okay, he took a hydrogen as an example to explain the model. So that's why heading is like this, Bohr model for hydrogen atom. Now according to this model, it consists of 5 postulates. First postulate is the electron in an hydrogen atom can move around the nucleus in certain fixed path called orbit or shell or level. So according to Bohr model, okay, electron rotate around the nucleus. This is nucleus, and electron rotate around the nucleus in certain fixed path. These fixed paths are known as shell. Electron rotate around the nucleus in certain fixed path. These fixed paths are known as level. They are known as level or shell or orbit. They are known as orbit or level or shell. The electron in a hydrogen atom can move around the nucleus in certain fixed path. These fixed paths are known as level or orbit or shell. They are K, L, M, N, etc. Or you can write it as N is equal to 1. K shell is also known as N is equal to 1 shell. L shell is known as n is equal to 2 shell. M shell is known as n is equal to 3 shell. N shell is known as n is equal to 4 shell. This is first shell, also known as K shell. This is second shell, L shell. N is equal to 2 L shell. Now third shell, okay, third shell, n is equal to 3 M shell. Fourth shell, n is equal to 4 N shell. So according to Bohr model, its first postulate is electron revolve around the nucleus. Electron rotate around the nucleus in certain fixed path. These fixed paths are known as level or shell or orbital. Orbit. Level or shell or orbit. O-R-B-I-T. Orbit. N is equal to 1 or K shell, N is equal to 2 or L shell, N is equal to 3 or M shell, N is equal to 4 or N shell, etc. 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 I think it's clear. Second postulate. Each orbit is associated with a fixed amount of energy. So they are quantized. Actually, each orbit is having a definite amount of energy. So for example, energy of first orbital is E1. But energy of second orbital is different. It is E2. Energy of third orbit is different, E3. Each orbit is having a definite amount of energy. Each orbit is having a fixed amount of energy. Okay, so we can call them as they are quantized. Quantized means each is having definite energy. Each orbit is having definite energy. Okay, so in a single term we can say that they are quantized. Each orbit is having a fixed amount of energy. So fixed amount of energy. Instead of that fixed amount of energy, we are using a single word, quantized. Quantized means fixed energy. So each orbit is quantized. Each orbit is quantized. That means they possess a definite amount of energy. If first orbit is having E1 energy, second orbit will have different energy, let it be E2. Third orbit will have different energy, let it be E3. I think it's clear. Now, so these orbits are also known as energy level or energy shell or energy orbit. So these levels are also known as energy level or energy shell or energy orbit, because they have a definite amount of energy. So they are, instead of level, shell or orbit, they are known as energy level or energy shell or energy orbit. I think it's clear. So according to we are discussing our third atomic model. Already we discussed Bohr, J.J. Thomson model, that is Thomson's model or plum pudding model. Second model, Rutherford's model. Then moving on to third one, that is Bohr model, and he proposed model for hydrogen atom. So heading is Bohr model for hydrogen atom. Now, this model consists of 5 postulates, and first postulate is the electron revolve around the nucleus in certain fixed path. These fixed path, it's a fixed path. These fixed path are known as level or shell or orbit. KLMN or n is equal to 1, 2, 3, 4, etc. Now each orbit is having a definite amount of energy. All of them have a definite, they are having a fixed amount of energy. So fixed amount, single term for fixed amount is fixed or definite amount of energy is quantized. So each orbit is quantized. So they are known as energy level or energy shell or energy orbit. I think it's clear. Moving on to third postulate. As long as electron revolve or rotate in a fixed path, it will not lose or gain energy. That means if you consider hydrogen atom, in hydrogen atom, electron is present at n is equal to 1, right? K shell. So this is, electron is present at K shell. This is K shell. Let this be the electron. N is equal to 1 shell or K shell, right? Now, let this be n is equal to 2. This be n is equal to 3. Let this be n is equal to 4, etc. Okay. Now, in hydrogen atom, electron is present in K shell, that is n is equal to 1, right? N is equal to 4, okay. In hydrogen atom, let this be hydrogen. In hydrogen atom, electron is present at n is equal to 1, that is K shell. Now, as long as electron revolve in a fixed path, when it's revolve in a fixed path, when it's rotate in a fixed path, when this electron rotate in a fixed path, it will not lose or gain energy. As long as electron rotate in a fixed path, it will not lose or gain energy. Okay, electron rotate in a fixed path, it will not lose energy or gain energy. It will not simply lose or gain energy. But when, however, if some energy is supplied to an electron, now from outside, if I am supplying some amount of energy to this electron by heating an atom, or supplying electric energy to an atom, by supplying energy from outside, that electron will absorb energy. That an electron will absorb the energy supplied, right? And it will excite to, it will move to some higher energy level, here or here or here. It will move on to some higher energy level. Okay, so I will explain once more. As long as electron revolve in a fixed path, so when an electron rotates or rotates in a fixed path, it will not simply lose or gain energy. It will not simply lose or gain energy, but somehow if some energy is supplied, however, if some energy is supplied in the form of electric energy or heat energy, if some energy is supplied to an electron, at that time it will absorb energy. Okay, then it will excite to some higher energy level. It will move to some higher energy level. For example, if you want to go to Goa, okay, if you want to go to Goa, without money you cannot go to Goa, right? Okay, without money you cannot go to Goa. Same here. Here, electron is simply rotating. So when an electron is rotating, it will not lose or it will not gain energy. You cannot simply go to Goa without money, right? Right, but if somehow you got money by some way, somehow you got money, then you can go to Goa, right? Same way, if some energy is supplied, then that electron will absorb that energy and it will move to higher energy level. I think it's clear. So an electron revolve in a fixed path. It will not simply lose. It will not lose or gain energy. But if some energy is supplied from externally, at that time it will absorb energy and it will move on to higher energy level based on the energy absorbed. If little bit energy is absorbed, it will move from K shell to L shell. If more energy is absorbed, it will move from K shell to M shell. If little more energy is absorbed, it will move from K shell to N shell. So based on the amount of energy, for example, if I am giving 25,000 to you guys, you will go to Goa to celebrate by using that money. But if I am giving 1 lakh rupees, you will go to Simla. Now if I am giving 25 crores, you can go to Los Angeles, somewhere else, right? You can go to Los Angeles or US or anywhere to celebrate with that money, right? So based on the amount given, you will choose the place. Same way, if little bit energy is given, it will move on to nearby higher energy level. But based on the energy supply, more energy is applied, absorbed, or more energy is given, that electron will move on to higher energy level. Moving on to fourth postulate. An electron can revolve only on those orbits which satisfy the condition MVR is equal to NH by 2 pi. N can have value 1, 2, 3. MVR means it's angular momentum. MVR is angular momentum. Angular momentum of an electron is an integral multiple of h pi. That means an electron can rotate only on those orbits which satisfy the condition MVR is equal to. That is, MVR means angular momentum. Angular momentum is equal to NH by 2 pi. So, an electron, N can have value 1, 2, 3, etc. That means an electron, MVR will be first orbit. Here, moving on to next fourth postulate. An electron can revolve only on those orbits which satisfy the condition MVR is equal to NH by 2 pi. MVR is angular momentum. MVR is angular momentum. MVR is angular momentum of an electron. MVR means it's angular. A-N-G-U-L-A-R. Angular momentum. So, momentum of an electron. So, MVR is equal to NH by 2 pi. So, an electron can revolve only on those orbits where MVR is equal to NH by 2 pi. N can have value 1, 2, 3, etc. What is the meaning of this? I'll draw another figure and explain this one. Please listen carefully. Now, here, if you consider an atom, let this be the nucleus. Let this be the first shell, N is equal to 1 shell or K shell. Let this be N is equal to 2 shell or L shell. Let this be N is equal to 3 or M shell. Now, you can see so many gaps here, right? K, L, M. You can see so many gaps here, right? Here. You can see so many gaps there, but electrons are not Electrons are forbidden to move to these gaps. Electrons are forbidden. They are not allowed to move to these gaps. Okay, they are not allowed to come to these gaps. They are permitted to move only on orbit. That is this idea. Actually, this postulate shares the idea. Electrons are not allowed to move to these gaps. They are permitted to move only on orbit. Okay, this is what this postulates tell us. An electron can revolve only on those orbits which satisfy the condition mvr is equal to nh by 2 pi. Mvr is angular momentum of an electron is an integral multiple of h by 2 pi. That means it means mvr, that is momentum due to rotational motion, that is angular momentum. Rotation due to momentum due to rotational motion. Here electron is rotating, so momentum due to rotational motion is angular momentum. Now, angular momentum value will be equal to nh by 2 pi when n value is equal to 1. When n value is equal to 2, n value is equal to 3. Okay, angular momentum will be equal to nh by 2 pi when n value is equal to 1. That is here. For n is equal to 1, that is in this orbit, angular momentum will be equal to nh by 2 pi. N is equal to 1. Now, second is in this orbit, angular momentum is equal to nh by 2 pi because n value is equal to 2. Now for in this orbital, angular momentum value will be equal to nh by 2 pi. Okay, this shows that an electron can only revolve only on those orbits which satisfy mvr is equal to angular momentum is equal to nh by 2 pi. For this orbit, n value is 1, so mvr will be equal to nh by 2 pi, 1h by 2 pi. Angular momentum is satisfied, that means electron can move in this orbit. Then here n value is equal to 2, so mvr is equal to nh by 2 pi, n value is equal to 2, so electron can move in this orbit. It's permitted. Now in this orbit n value is equal to 3, so mvr is equal to nh by 2 pi, n value 3. That means here also momentum due to rotation, that is angular momentum, will be equal to nh by 2 pi. So electrons are permitted only on these spaces which satisfy the condition mvr is equal to nh by 2 pi. That means they are not allowed to move to these gaps. They are allowed to move only on those orbits. I think it's clear. An electron can revolve or rotate only on those orbits which satisfy the condition mvr is equal to nh by 2 pi. They are not allowed to come here because here n value can have value 1, 2, 3, 4. 1 means here in this orbit. So in this orbit mvr is equal to nh by 2 pi. 2, that is here. In this orbit angular momentum is equal to nh by 2 pi. Here n value is equal to 3. So here mvr is equal to nh by 2 pi. So an electron can revolve only on those orbitals which satisfy the condition mvr is equal to nh by 2 pi, and this condition is satisfied only on orbit 1, 2, 3, 4, 5, etc. That means the electrons are not permitted to, they are not allowed to come to these vacant spaces. This is what fourth postulate means. I think it's clear. Moving on to fifth postulate. I think it's clear. Moving on to fifth postulate. Now, fifth postulate. If an electron absorbs energy, okay, it will excite to higher energy level. If an electron absorb energy, it will excite to higher energy level. Then change in energy delta E is equal to EF minus EI. Final energy minus initial energy, EF minus EI. Delta E is equal to EF minus EI. Okay, so that means if this electron absorbs some energy, okay, let the energy of light be h nu. It absorb light energy. Let the energy of light be h nu. So this electron absorbs some light energy and it will excite you. It is exciting to higher energy level. Let the level be n is equal to. So it's exciting from 1 to 2. It is jumping from 1 to 2. So here an electron is present in n is equal to 1 and that electron is absorbing light energy. Let h nu be the energy of light. It is absorbing light energy and it's moving from n is equal to 1 to n is equal to 2. So what is delta E? Change in energy is equal to final energy minus initial energy. Here final energy is E2. Let this be the, okay, let's energy of second shall be E2 and energy of first shall be E1. Okay. So here electron is moving from E1 to first shell having energy E1 to second shell having energy E2. So change in energy is equal to final energy, that is E2 minus initial energy, that is E1. Delta E is equal to E2 minus E1. What is delta E? According to Planck quantum theory, E is equal to h nu, right? H nu, E is equal to h nu. So you can write here h nu is equal to E2 minus E1. Because according to Planck's quantum theory, E is equal to h nu. So instead of delta E, delta is there, but anyway, for E you can write h nu. So h nu is equal to E2 minus E1. I think it's clear. This is the fifth postulate. If an electron absorb energy, okay, it will move from that normal ground level to higher energy level. Okay, then the difference in energy is final energy minus initial energy. If an electron moves from first energy level E1 to second energy level E2 by absorbing energy, then change in energy is E2 minus E1, final energy minus initial energy. Okay, what is the h nu? So it is the light absorbed. That change in energy is the light absorbed. Okay, due to that light energy, it is moving from one orbital to another. So the change in energy is the light absorbed. H nu is equal to E2 minus E1. I think it's clear. So these are the postulates of Bohr model, Niels Bohr model. I think it's clear. Moving on to next topic.